Hi, in this video we're talking about discrete random variables, the binomial distribution with Rgruoo. So Whataburger is a burger chain and it's running a contest. If you buy a burger, it comes with a pull-off tab. 25 of the tabs say, you win a free small fry, while the remaining tabs say, better luck next time. If you buy a burger, your chances of winning is 0.25. However, what if you decide to buy burgers for 10 of your friends? What is the probability that exactly 3 of them will win a free small fry? What's the probability that half of them will win a free small fry? What's the probability that all of them will win a free small fry? All of these questions can be answered when we recognize that this problem is an example of a binomial random variable. So what is a binomial random variable? So let's talk about a binomial experiment. A binomial random variable comes from a binomial experiment which has the following characteristics. The first characteristic that it has to have is that it's a fixed number of trials. So if you know how many trials there are going to be, a lot of times this is the same as the sample size. If you're taking a sample, because you do a trial for each individual in the sample. So if there's a fixed number of trials, that satisfies the first condition. The number of trials is designated by the letter N. 2 outcomes, one is labeled a success and the other is labeled a failure. It's also important to note that a probability of a success is denoted with a lowercase p, and a probability of a failure is denoted with a lowercase q. Notice the little formula here for q is the complement of p. So using the formula of complements, we do 1 minus the probability of it occurring. So the 1 minus the probability of a success would give us q, the probability of a failure. So again, 2 outcomes. One is labeled a success, one is a failure. And you can group outcomes together. Like if you had M&Ms, you could say getting a blue or a green M&M would be a success and any other color would be a failure. So even if there's more than 2 total outcomes, you can group outcomes together. Also, the probability of a success is the same for each trial. So it doesn't change every time you do another trial. The probability of it being a successful trial is the same. And all the trials are independent of one another. So whatever happens in one trial shouldn't affect what happens in the probability of a success occurring in another trial. This here, number 5, isn't one of the characteristics as far as one of the properties, but it is something we talked about in an earlier video, that random variables are designated with an X, and it describes the number of successes. So we're going to decide whether each of the following is a binomial random variable. So in other words, does it satisfy the 4 conditions? All right, so let's check it out. So a coin is tossed 10 times. Let X be the number of heads. So fixed number of trials? Yes, because it's 10 trials. And then 2 outcomes. And the answer here is yes, the outcomes are heads and tails, with heads being a success. The third is that the probability is the same for every trial. And that's true because the probability of rolling a heads, or not rolling, tossing heads is 50% or 0.5. And that's the same every time you toss a coin. And last, the trials are independent. So that's true. Flipping a coin and getting heads on one toss isn't going to affect what you toss the next time around. So this one is binomial. All right, so what about this next one? 5 basketball players attempt a free throw. Let X be the number of throws made. So is it a fixed number of trials? I would say yes, because there's 5 trials. By the way, there were 10 up here. 2, are there 2 outcomes? Yes, they are make or miss a basket. The success would be making a basket. 3, is P the same for every trial? At first glance, you might think, yes, P is the same for every trial because you've got a 50-50 chance of it landing in the basket because you either make or miss. However, other things go into play here, such as skill level of these 5 basketball players. So some may do better at free throws than others. So with that said, the probability is not the same because we're dealing with 5 different players who have 5 different skill levels. So their probabilities of making a free throw are not the same. So this is not binomial. All right, so a random sample of 250 voters is chosen from a list of 10,000 registered voters. Let X be the number who support the incumbent mayor. So for re-election. So is this a binomial experiment? So first off, is there a fixed number of trials? Yes, there's 250 because we're going to choose 250 voters. Are there 2 outcomes? Yes, they either support or not support. 3, probability the same? Yes, it's 250 out of 10,000 every time. And are the trials independent? I would say yes, because the individual voters are independent of one another. So this would be a binomial distribution or binomial experiment as well. Okay, so moving on. A biased coin has a probability of 0.6 of coming up heads. The coin is flipped 3 times. Let X be the number of heads that comes up. Create a probability distribution that lists the probability for all possible outcomes. So let me just show you kind of how this works. All right, so you are flipping a coin 3 times. So if you flip a coin 3 times, you can get heads, heads, heads. You could get, let's do this. Let's see. You can get heads or tails for the first flip, heads or tails for the second, and you can get heads or tails for the third. All right, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes. We have heads, 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 and we have heads, heads, tails. Then we have heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So those are all the possible outcomes, but our X is the number of heads that come up. So we need to count how many heads are in each scenario. So this is 3 heads, 2, 2, 1, 2, 1, 1, 0. So here are our possibilities, our X's. You can have 0 heads, 1, 2, or 3 heads. Now the probabilities, you might think, oh, these are pretty easy to come up with, but let's look at how to find the probabilities here. Okay, so let's do the probability of no heads. So the only way to get no heads is to do tails, tails, tails. So if we're doing tails, 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 that's the probability that the first one's tails, the second one's tails, and the third one is tails. And because these are events in succession, we are going to multiply together. Hold on. Sorry about that. I lost my screen there for a second. Anyway, because these are events in succession, we're going to multiply these together. Now, we need to know what the probability of a tails is. Now, the probability of heads, which is P, by the way, because that's the probability of a success, is 0.6. So that means the probability of a tails, which is our Q, is 1 minus 0.6, which would be 0.4. So probability of heads is 0.6, probability of tails is 0.4. Why is it not 0.5? Because here it says it's a biased coin, which means it's weighted. So we're going to do 0.4 times 0.4 times 0.4. And if you multiply 0.4 times itself 3 times, you get 0.064. So I'm going to fill this in. Okay, so next, we've done, I'm going to mark off the ones we've done. We've done this one right there. Okay, so next we need to figure out the probability of 1 heads. So how can we get 1 head? So let's highlight these. 1, 1, 1. There are 3 ways that it can happen, right? So let's write this out. What's the probability that we have a total of 1 head? So that could be the probability that we get heads, tails, tails, or, oops, let me write it this way, or we get tails, heads, tails, or tails, tails, heads. And because this is or, you find the probability of each one of these events, and we add them together. And they're not mutually exclusive, so you don't have to subtract any overlap. But to find each one individually, these are events. Sorry again. Alright, sorry about that again. I keep losing my screen. So because these are events in succession, we find the probability of each of the individual events and we multiply them together. So for the probability of heads, tails, tails, we find the probability of heads, the probability of tails, and the probability of tails, and we multiply them together. And then for the next one, probability of tails, heads, tails, we find the probability of tails, the probability of heads, probability of tails, and we multiply those together. And then for the probability of tails, 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 heads, we find the probability of tails, the probability of tails, probability of heads, and we multiply those together. So again, the probability of heads is 0.6 and the probability of tails is 0.4. So recall that. So here we go, 0.6 times 0.4 times 0.6, 0.4 times 0.6 times, oops, let me go back. I've messed this up. Let me start over. Okay, trying again. 0.6 times 0.4 times 0.4 plus 0.4 times 0.6 times 0.4 plus 0.4 times 0.4 times 0.6. There we go. There we go. All right, so when you do these, 0.6 times 0.4 times 0.4 plus 0.4 times 0.6 times 0.4 plus 0.4 times 0.4 times 0.6, let's see what we get. Let's open up a calculator. If we have I think it was 0.6 times 0.4 times 0.4. We get 0.096. And then basically you are getting 0.096 for each one because each one is 2 0.4s and a 0.6. And then if you add those together 3 times, that's the same as multiplying by 3, you get 0.288. So we'll add this in here. Now, if we continue to do this, you can see that this will take us a good while to try to figure this out because you've got to figure out all the different combinations. Now, there are some formulas, but we've not learned everything that you would need for the types of formulas that would be useful here. So you can see that this will take a while. So what I'm going to do is I'm going to work these out on this part of the notes that I will post to you. But I'm going to go ahead and fill in what the answers are because otherwise we'll be here for quite a while just trying to work through this problem. So if we did all the ways that you can get 2 heads, so let's see, that's this one, and this one, and you went the same route as you went here, that ends up being 0.432. And then if you find the probability of just 3 heads, which is a little bit easier because there's only one way for that to occur, that ends up being 0.216. And because the outcomes are all listed here, all the random variables, if we were to add these together, because this is a probability distribution, the sum does add up to be 1. You can double check. Anyway, if you would like to continue going through and try to find the probability of 2 and 3 to make sure you get the same answers, you can go ahead and do that, but I will definitely have it worked out for you here on this page when you looked at the filled in notes. Okay, so looking at this next section, using the previous probability distribution to find the following probabilities, we have the table listed here. The probability of exactly 2 heads is right here, 0.432. The probability of no heads is the same as the probability of 0 heads, so that's 0.064. Okay, so now let's get to the next 4. These are using some inequality terminology. When we have inequality, that means that it's not equal to a specific number, but it's less than or greater than, less than or equal to, greater than or equal to a certain number, and usually includes multiple numbers as possibilities. So when we say less than 2, the numbers that can be less than 2 are 0 or 1. 2 would not be included here because 2 is not less than 2. And so because our key word implied here is or, we're going to add those 2 probabilities. So we're going to add 0.064 with 0.288, and we're going to get 0.352. Uh-oh. Something happened and it's not working. I'll try it again for you guys. Okay, there we go, 0.352. Having all kind of technical difficulties for this video. Probability of more than 1. So more than 1 doesn't include 1. It's the numbers greater than 1, so that's 2 or 3. So again, the word or is implied, so we have to add the probability of 2 with the probability of 3. And the probability of 2 is 0.432. And we're adding the probability of 3, which is 0.216. And for this one, we would get 0.648. Now, at least means 1 or more. At least means 1 or more. So, probability of at least 1 is 1 or 2 or 3. So, we're going to add the probability of 1 with the probability of 2 with the probability of 3. And we get 0.288 plus 0.432 with 0.216. And for this one, we get 0.936. So I'm going to just mark each one of these so you can see where the answer was. And then at most 2 is no more than 2. So that most 2 would be 0 or 1 or 2. So it does include 2. So we're going to add the probability of 0 plus the probability of 1 plus the probability of 2. So we are adding 0.064 plus 0.288 plus 0.432, and we get 0.784. All right, fun times. All right, so speaking of formulas, we could shortcut it. What we were doing up here, we could shortcut this for these binomial probabilities by using this crazy formula, but you'll notice there's some notations here that we definitely have not learned in this class. So we're going to move on from this. We are not going to use this formula, so don't even bother writing it down. We're going to use Rgruoo to calculate binomial probabilities. So we can calculate probabilities such as the ones above here that we use to answer these questions there. We can use Rgruoo to do that. It's actually pretty simple. We're going to use the Probability Simulations tab. So, you know, when you look on the left-hand side, there's a Data tab, there's a Plots tab, there's an Analytics tab, but then there's also a Probability Simulation tab. So you want to click on that, and there's a drop-down that says Probability. So in the drop-down, you want to click on it, you want to choose Probability Calculator. And once you choose Probability Calculator, we're dealing with discrete random variables, so you want to choose discrete. So make sure you choose discrete. And once you do that, another pop-up box will appear. So again, Probability Simulations tab, in the drop-down, choose Probability Calculator, choose discrete. Now, once you do this, you will have this little box here pop up, and you've got two possibilities: values to probability or probability to values. For these, what is going to happen is they're going to give us values, and we're looking for the probability. So you want to keep this one on the left. You want to keep that one checked. And so the answer will go here. So you don't type anything here. You go to where it says distribution and make sure binomial is chosen. If it's not chosen, you click on the drop back down and choose it. And then where it says number of trials, you're going to put however many trials there are. And where it says probability of success, you figure out what a success is. And in one of the previous scenarios, we said a success was flipping a coin and it landing on heads. So what is the probability of it being a heads? And in that case, the coin was biased, so heads would be 0.6. I have 0.8. This doesn't necessarily represent anything specific. And then once you do that, you have this little drop down here where you can choose less than, greater than, equal to. So whatever the probability you're looking for, you figure out what wording, whether it's the equal sign or some kind of inequality, and you click on this drop down and choose the correct word, enter your value. Now, let me just go back through here. We enter the number of trials. You want to choose whether it's equal, above, below, or between, or outside in the drop down. Those are your options. Then you include the value in the box like I did here. Now, if you click graph, it gives you a nice visual, but you don't have to. I like clicking graph because the visual really helps you to really understand what it is you're finding, as you'll see in a moment. So you don't have to click graph, but I usually do, and then you click the preview button. And so if you look here, I did that with binomial distribution, a number of trials 10, probability of success is 0.8, and I was trying to find the probability that it was equal to 5. So that's what this is finding. And so you'll see it graphs it for you. And each of these bars, if you'll recall, represents a relative frequency, but it can also represent a probability. So the probability of exactly 5 is shaded, and you can see that is 0.0264 right here. And that would be the number that it would give you in the calculator, in the Rgruoo calculator. So it's fairly quick. Again, you don't have to graph it, but I do like the graph because it visually shows you what it is you're finding. So check out this one. Let me just show you other options. This one was for equal 5. What if we wanted to do more than 5? So let me just show you. If you clicked here and changed it to above 5, notice this little box pops up. So this box is a check box, and you check it if you want to include the value. So you have to decide, is 5 included? Notice I kept it unchecked here because I'm just doing greater than 5. That doesn't include 5. And so then you can see here that your probability is including all of the bars that are shaded. So if I want greater than 5, it's going to shade the bars 6, 7, 8, 9, and 10 because those are the numbers greater than 5. Isn't that neat? And then this is a way you can go check it visually. You can say, did it add the correct probabilities together? Well, hey, it did, because if I'm looking for a number greater than 5, a probability that is greater than 5, I want it to shade the bars that are greater than 5. It did, and the probability is 0.96721. So again, such a great tool, especially the visual. So I really encourage you to click graph before you preview. Now, had we wanted to include 5, had we had something like that it was at least 5, that'd be 5 or more, you would have clicked this button to include 5. And then in that case, you would have seen the 5 shaded, and this would be slightly different. So let's go back to the Whataburger scenario. This is a binomial distribution. If you'll remember, we're getting burgers for 10 friends, so that's a fixed number of trials. There are 2 outcomes. You either win a fry or you don't win a fry. A success is winning a fry. The probability of a success is 25%. Because if 25% of the tabs say you win, that means you got a 25% chance, or 0.25, of winning a free small fry. And the probability is the same for every trial. And then the trials are independent of one another. So it does meet all the criteria for being a binomial distribution, which means we can find the probabilities this way. So it says, what is the probability that exactly 3 of them will win a free small fry? So it's helpful to note a couple things. So what is N and what is P? So N is 10 trials. And then the probability of a success is 0.25, because you got a 25% chance of winning. So we're going to go to Rgruoo, and we're going to put this in. So let me mosey over there. All right, so I'm going to close out what I have over here. I've got a couple things going on here. Okay, so you're going to click on probability simulation. In the probability drop down, you're going to click on the first choice, which is probability calculator. And as I said, click discrete. Once you do, a box pops up. It already says values to probability, so we leave it. The distribution is binomial. You have other choices, but you want to leave it binomial. We'll only use binomial in this class. The number of trials, that was 10. Probability of success is 25%, but you need to put it in as a decimal. So 25% as a decimal is 0.25. And we're trying to find the probability that it's exactly, which is another word for equals, 3. And then I'm going to hit graph so I can see it and preview. And here we go. We can see the graph. We can see that it's only shaded 3, so that's a probability of 3. And then if you look right here, the probability of 3, right above the graph, it says probability of x equals 3 is 0.2503. 0.2503. Okay, so want to go back here, and we have that written down. All right, so now let's figure out what is the probability that half will win a free small fry. So how many is half out of 10? Well, that's 5. So we can quickly go back here and just go to basics and change the equal to number from 3 to 5. Hit our preview button. It now has changed the shading to 5, and you can see the probability is 0.584. Oh, I left out a 0. 0.0584. Okay. So one more. Let's go back to the slide. What's the probability that all of them will win a free small fry? So how many is all? That would be 10. So again, going back to the basic screen, just change the 5 to 10. And now you can see, now you actually can't see the 10 shaded. And the reason is because the probability of a 10 must be so small that you can barely see the probability. It barely registers, and it makes sense here. We've got the number 9.537e to the negative 7. It says 07, but it's just negative 7. And then if you will recall what that means, it means that I need to take this 9.537, I need to take the decimal, and I need to move it 7 places to the left. 1, 2, 3, 4, 5, 6, 7, new decimal, and everywhere there wasn't a number, we replace with we put a 0. So that's a very, very, very small probability. So that was easy enough, right? So now Whataburger is still running this contest, and we've got some different probabilities. We want to now know what is the probability that less than 3 of them will win a small fry. So which numbers are less than 3? I find it really helpful to write these out. So the numbers less than 3 are 0, 1, or 2. So normally we would add together the probability of 0, 1, or 2, but we can let Rgruoo do this for us, okay? So go back to basics, and the number's less than 3, so I'm going to change the equal to sign to below 3, and 3 is not included because it's not less than 3, so I'm going to uncheck that and then hit preview. Make sure that 0, 1, and 2 are the ones that are shaded. Those are the numbers less than 3, and you can see the answer is 0.5256. Very, very quick. Very, very quick. Let's do another one. What's the probability that more than 7 will win a small fry? So more than 7, we're going to be adding the numbers 8, 9, or 10. And quickly we can let Rgruoo again do this for us. All right, so just go back to basics. It's still 10 trials. Probability of success is still 0.25. Now we're doing above 7. 7 is not included, so uncheck it. And then just look to make sure. Now, because we're doing more than 7, we would shade 8, 9, and 10. And basically those probabilities are so small you can't see the shading, and you can see a very small number here, 0.000418, and I'd probably round it to 4 decimal places, so 0.0004. What's the probability that no more than 4? So no more than 4 is less than or equal to 4. That includes 0, 1, 2, 3, and 4. It does include 4. So again, let me just start over just to remind you the full steps. Alright, so going to probability simulation, and the drop down, choose probability calculator discrete. Leave everything as is until you get to the number of trials. We enter 10. Probability of a success is 0.25. And now we are doing no more than 4. So that is below 4, and it includes 4, so make sure that you have it checked. And I'm going to choose graph because, again, I like to see it. And then, are the numbers shaded no more than 4? Yes, those are the numbers 0, 1, 2, 3, 4. Those are shaded. And above that, I see the probability is 0.9219. And last, what's the probability of at least 8? The probability of at least 8 is greater than or equal to 8, which is the probability of 8, 9, or 10. And again, you could find the individual probabilities and add them up. Or you can just go back to our Rgruoo, excuse me, and we want above 8, including 8. And you're not going to be able to see any shading because, again, we've gotten to the small probabilities, and those small probabilities do add up to be 0.0004158, which again rounds to 0.0004. Okay, so there's one example. Oops, and you did not see, I did not go back here. So, there we go. Those are the answers to those solutions. All right, so moving on to the next example. This is airline flights. At a particular airport, 81% of the flights arrived on time last year. If 15 flights are randomly selected, find the probability that, and I give several probabilities that you need to find. So first, check to make sure it's a binomial distribution. There's a fixed number of trials. It's 15. The probability of a success is 0.81, which is the same. It's 81%. It's the same for every trial. There are 2 outcomes. Either the flights arrive on time or they don't, and the trials are independent. So what's the probability of exactly 10? Exactly 10 means equal 10. So let's go to our Rgruoo, and probability calculator discrete. There are 15 trials this time, and the probability of success is 0.81, and we want to know when it's exactly 10. Graph it if you want to, preview, and we get 0.0904. 0.0904. All right, let's look at the next one. Exactly 12. So the probability that is exactly 12 is the same as equaling 12. So let's just change the 10 to a 12. And we get 0.2489. You see this goes fairly quick. And you can see only 12 is shaded there. Next one, what's the probability of 11 or fewer? So 11 or fewer would be less than or equal to 11. So it's 11 or less, and it includes 11. So if I go back here and choose a probability discrete calculator with a number of trials of 15 and a probability of success of 0.81, we're going to go below 11, and 11 is included, so make sure we've checked it. Include the value. And you can see we've got shaded the number 0 up through 11. You can't see anything below 6 because it's got such a low probability of occurring. Yeah. So everything is shaded correctly, so then we get 0.3146. All right, so going back, fewer than 10. So does fewer than 10 include 10? It does not. So let's go back here, and we'll keep it as below 10, and we're going to uncheck the included button, or the included box, because it doesn't include 10. And so you can see 9 and below are shaded. Those are the numbers that are below 10. And we get 0.49. I'm sorry, I left off at 0 there. 0.490 if I round it to 3 decimal places. What's the probability of more than 9? More than 9. And you can't see that. There you go. Probability of more than 9. All right, so we're going to change this to above 9, and it doesn't include 9. More than 9 would be 10 and above. It's shaded correctly. We get 0.951, and then I'll just add a 0 on the end to round to 4. And then the probability of 11 or more. There you go, probability of 11 or more. So probability of greater than or equal to 11, because it includes 11. Oops. So we change it to above 11, including 11. And you can see 11 or more is shaded, and we get 0.8606. So all of those are very, very quick. Very quick to do. You can either for your work, you can write out the input that you've put into the basics box that you put here. You can also provide screenshots of what you entered and use that for your work. All right, so why don't you pause the video and attempt the next several here, A, B, C, D, E. Real quick, it says, according to Nielsen report, 65% of internet searches in May 2010 use Google. If a sample of 25 searches are randomly selected, find the probability that, and then answer the question. So why don't you attempt these with a binomial calculator, probability calculator on Rgruoo, and then come back and check your answers. All right, so for these, the number of trials was 25. The probability of success is 0.65. So fixed number of trials, 2 outcomes. The outcomes is they either use Google or they didn't. Probability of success was 0.65, and their probability is the same, and the trials are independent. So N is 25, P is 0.65. You'd put those in the calculator, and then you would do equal to 20 for this one, and you get 0.506. The next one, fewer, would be below 15, but it's 15 or fewer, so it includes it, so equals. So you would check the box, and you get 0.3697. More than 22 does not include 22, so you would choose above 22 without the checkbox, and you have 0.0021. Fewer than 12 is the same as less than 12. It does not include 12. So again, do below 12 and then uncheck the box, and you get 0.0255. And last, 17 or more, that includes 17. So click above 17, click the checkbox to include 17, and you get 0.4668. Okay, so a couple of more formulas. These are pretty basic. We've talked about how to find the mean of a random variable. You multiply the x times let me just remind you, we did the mean of the random variable, which is the same as the expected value, was the sum of x times p of x, right? Remember, we did that. We also used Rgruoo to calculate that. Now, if you recognize that something is a binomial random variable, then you can use the formulas below instead of the one above here. So we're going to use these instead if it's binomial. So you can't use these unless they're binomial. So instead of the mean of the random variable equaling the sum of x times p of x, it's now just simply n times p. Pretty basic. Skip down to standard deviation. the standard deviation is the square root of n times p times q. The variance is the square of that, so I have that in there. It's just npq. But if you want the standard deviation, you find npq, multiply them together, and take the square root. And then just remember that q is the same as the complement of p. It's 1 minus p. Okay, so let's do this next example. We've got, looks like 2 more examples. Okay, a statistical abstract of the United States reported that 67% of students who graduated from high school in 2007 enrolled in college. 30 high school graduates are sampled. Find the probability of that, and then we're going to find the following probabilities. So a couple things. 67% of students who graduated enrolled in college. So the probability of success, a success being enrolling in college is 0.67. So 2 outcomes. You can either enroll in college or not. There's a fixed number of trials. It is 30. Probability of success, 0.67, is the same for every trial, and the trials are independent. So here we have it. So now we want the probability of exactly 18. So we're going to go to Rgruoo, and we're going to do probability simulation. In the drop down, choose probability calculator, choose discrete. The number of trials is 30. The probability of a success is 0.67, and we want to know when it's exactly or equal to 18. And it looks like 0.1068 is our solution there. All right. So next, the probability that it is more than 15. So more than is above. It does not include 15. So I'm going to go back to basics and change the equal to above, because we're doing more than 15. I'm going to change this number to 15. And above 15 does not include 15. So uncheck the box. And we get 16 and above is shaded, and we get 0.9601. Probability of fewer than 20 fewer is another word for less than 20, and that does not include 20. So I'm going to change this to below 20, uncheck the included box. So now I've shaded the bars below 20, 19 and below, and the probability is 0.4. Okay, so last question. How many of these students would you expect to enroll in college? So keyword here, expect, think expected value. So if we were to repeat this experiment over and over and over and over again, and we were to find the average of the outcomes, that would be the expected value. Also denoted as E of x, also denoted as mu x for the mean of the random variable. And because this is a binomial experiment, we can use the formula here, which is n times p. So n in this case was 30, and 0.67 is the probability. So then if we go, I just want to show you, if you go to Appley's and calculators and maximize the Desmos calculators, you have 4 calculators to choose from. You can see that I did 30 times 0.67, and I got 0.20, I'm sorry, you got 0.20, I can't say it right, and I got 20.1, 20.1. So let me put that in. One more. 65% of people pass the state driver's exam. So that's probably our P. P is equal to 0.65. So because you can either pass or you don't pass. So 2 outcomes. Probability of success is the same for every trial. Trials are independent. A group of 50 individuals. So there's our number of trials that are fixed. who have taken the driver's exam as randomly selected, find the probability that between 30 and 35 of them pass on the first try. So what's cool is that Rgruoo can quickly do this for us. Okay, so let's go to back to probability simulation, choose probability calculator discrete. The number of trials was 50. Probability of success is 0.65. All right, so then we want to go between the lower tail would be 30 and the upper tail would be 35. And look, we've got shaded 30, 31, 32, 33, 34, and 35 shaded. Oh, wait. We did, yeah, we wanted 30 to 35. And those are all shaded. And so we get 0.6262, which if you were using another method, such as TI calculator, you can do this, but it is so much quicker this way. So just going back and showing you what I did, chose the calculator, put in the number of trials and the number of success, or the probability of success, and I chose between, and then let me just show you. It says lower tail and upper tail, and you have to put in the number. So it's between 30 and 35, and it includes 30, so that's checked. If I didn't want to include 30, I'd uncheck it. If I didn't want to include 35, I wouldn't check it. And then that would go from 31 to 34. Let me just show you. 31 to 34. Yeah, this is 31, 32, 33, 34 shaded, but I wanted them included, so I'm going to go back and check them. So they are included, and now they're included, and the probability is 0.6262. So really fancy what the Rgruoo can do. If you have questions, please let me know, but that's all I have for you on this section. Have fun.